Hello everyone, welcome to this video. So in this video, we are going to discuss about the most important topics for JEE 2025. And after watching this video, you will come to know about all the concepts and how to apply them. And this will secure you at least 50% marks in the mathematics paper. So not only this topics, but its related topics. Okay, so this is the first property that you must know by heart. This property of integration is very useful and it is almost found in all the problems that you will see in JEE Advanced or JEE Main papers or even in any other competitive examinations. So integral of a to b fx dx is always equals to integral of a to b f of a plus b minus x dx. You can prove it by just using the substitution u equals to a plus b minus x. Correct? Okay. Let's go on and see the next one. This is minus a to a fx dx, and this is again a very important one. This is for identifying even or odd functions. So if you remember that fx is an even function, if f of x is equal to f of minus x, so it has symmetry along the y-axis. And f of x is an odd function if f of x equals to minus of f of minus x. So this is even and this is odd. So if you have an integral from minus a to a of this kind, then minus a to a f of x dx simply becomes 2 times 0 to a fx dx if f is even, and it becomes 0 if f is odd. This is a pretty quick exercise. I would suggest you to just do it mentally. Why is it 0? And lastly, but not the least, every limit problem or even some problems in sequence and series use this. This is the Riemann sum, or at least the general, very specialized version of it. So limit n tends to infinity 1 by n summation k equals to n f of k by n, where f is integrable. Then this summation, this limit of the sum is directly equal to 0 to 1 fx dx. And it's used in almost, I think, you can find a question from this particular topic in almost all of the JEE exams. Okay, let's move forward. So first of all, we have this question: if I equals to 2 by pi minus pi by 4 to pi by 4, and then we have to find this value of 27 I squared. And okay, so first of all, notice that whenever you have this minus a to plus a thing, you want to see if this is an even function or an odd function. Again, 1 plus e to the power minus sin x, if you see that this is fx, and if you do the fx equals to f of minus x check, it does not satisfy. And it won't satisfy the odd function as well. So we have to rule that out. But we can use the general property, which is always useful, which was the first property of a to b fx dx. If you remember this property, right? So we are going to use that property. And when you have the limits of the type minus a plus b simply becomes 0, right? So x just basically turns to minus x. Remember this as a thumb rule because you're going to use it. So if you apply that property, x becomes a minus x. So the first term becomes e to the power minus sin x. And cos of minus x is again cos x. So I don't think that matters. I think this was cos of 2x, if I remember correctly. So this should be cos of 2x dx. Okay. Okay, so this means that we can do the LCM here, and this would give you 2 by pi minus pi by 4 to pi by 4 e to the power sin x upon 1 plus e to the power sin x into 2 minus cos 2x. In this whole video, I'm not really going to solve each and every problem. So I will leave some parts as an exercise, and I would really hope that you can pick that off right now or maybe later and do it in under 2 to 3 minutes maximum. Please do not allow more time than that, because right now what we are trying to do is we are trying to apply the concepts as fast as possible. And we are not really trying to give ourselves time and room to get very better at problems. Okay, that's a different time. This is what we are doing here. We are trying to maximize our potential to solve in the fastest time possible by applying the concepts. So once you got this, you should realize that if you add all this, both these two copies of I, you should get something like 2i equals to, okay, we have like 2 by pi minus pi by 4 to pi by 4. And this e to the power sin x and this one will add up. And you will have a e to the power sin x plus 1 in the numerator, which will cut off to give you dx by 2 minus cos 2x dx. And this is going to be a simple integral. So I won't solve this one. You should try and solve it on your own and then just find out 27 I square. Great. Okay. So now let's go to quadratic equations. So the first property is if ax square plus bx plus c equals to 0, which is the general form of a quadratic equation, and alpha and beta are its roots, then we can split out the following properties, which are very important for solving problems. First of all, the sum of the roots is minus b by a. The product of the roots is c by a. Sum of the square of the roots is b square minus 2ac upon a square. And 1 upon alpha plus 1 upon beta, that is the sum of the reciprocal of the roots, is minus b by c. You can find out any combination of alpha and beta in symmetric polynomials using this properties only. You can in fact find it only using the first two, which are obtained. So these two are obtained directly from this equation. These are called the Vieta's relations. Now, if roots are real, only and only if b squared minus 4ac is greater than 0, which is also called the discriminant. And if it is not 0, if it is less than 0, then the roots are imaginary. And also remember, imaginary roots always occur in conjugates or pairs, which means if p plus iq is an imaginary root of an quadratic equation, then p minus iq is also a root. And this is true for not only quadratic equations, but for any polynomial equation with real coefficients. Remember that works for real coefficients only. Anyway, okay. And lastly, but not the least, if you want to form a new equation with roots, let's say f of alpha and g of beta, where f and g are functions you do not know or you may know, and they're different than simple identity functions, then you simply have to find out. I mean, this is your answer basically, but well, to answer this, you have to find out f of alpha plus g of beta and f of alpha into g of beta. That is sum of the roots and product of the roots. That is how the questions are formed, and that is how you can find the new equation. Okay, let's move on. So I think this is a problem from JEE Advanced as well, probably 2024 or something. So anyway, we are given this is a polynomial with real coefficients, is that f of 1 is minus 9. And we suppose that I root 3 is a root of this equation. Okay. Okay. So first of all, write down this equation 4x cubed plus 3ax square plus 2bx equals to 0. This is a cubic equation, true, but you can immediately reduce x equals to 0 is one of the roots because x goes up. And it becomes 4x square plus 3ax plus 2b equals to 0. And if I root 3 is an equation, is a root of this equation, then minus I root 3 must also be a root because imaginary roots occur in pairs. And then using Vieta's relations, we can say that the sum of the roots I root 3 minus I root 3 should be equals to minus b by a. So minus b is basically minus 3a here by a. So this is 0. So this would give us a equals to 0. Similarly, I root 3 into minus I root 3. This would be 3 minus I square, which is 1, equals to c by a. C is 2b, a is 4. So b would be equal to 6. Hope that makes sense. Okay. So a and b are found. And also f of x is given. And you're given that f of 1 is minus 9. So f of 1 is minus 9, which means that 1 plus a plus b plus c is equal to minus 9. And a is 0 and b is 6, right? Yeah, 6 plus 1, 7. So c plus 7 is minus 9, which should give you c equals to minus 16. Correct? Now, the roots of the equation are also like alpha 1 whole square plus alpha 2 whole square plus alpha 3 whole square plus alpha 4 whole square. This is what they are asking. But we are going to do it in a better way. So first, find out what fx is. Fx is simply x to the power 4. A is 0, so there is no cubic term. B is 6, right? So it's basically plus 6x square minus 16. Okay, so let's write it down in the new page. F of x is x to the power 4 plus 6x square minus 16. And obviously it has four roots, alpha 1, alpha 2, alpha 3, and alpha 4. Correct? Now, this can be obviously given as x square plus 2, I think, into X square plus 8 into x square minus 2, right? This is the factorization. Yes. So this would be the factorization. And of course, from this, you would get the roots are, you can set x square plus 8 equals to 0. You can get the two roots. You can get x square plus 2 equals to 0. Sorry, minus 2 equals to 0, and you can get the two roots. But that is beyond the point. What we are trying to do is alpha 1, alpha 2. In this alpha 1 to alpha 4, one of the alphas is basically negative of the other alpha. So 1 among alpha 2, alpha 3, alpha 4 is basically minus alpha 1. And similarly, so basically the roots are of the form this alpha and minus alpha, beta and minus beta. These are the four roots basically named as alpha 1, alpha 2, alpha 3, alpha 4. Because this is an even function. If x satisfies this equation, so does minus x. That's what you have to understand. Anyway, so you can see that the roots satisfy x square equals to minus 8. And so that means it will satisfy mod of x square equals to 8, right? And well, if it does that, then obviously two of these terms from alpha 1 will have 8 values. So 8 plus 8. Similarly, two of the other alphas will have a value of 2. So that is plus 2 plus 2. So 8, 8, 16 plus 2, 18 plus 2, 20. That should be your answer. Okay. So you see that using Vieta's relations, it was very easy. Let's go to sequence and series and learn a few basic things. If A1, A2, AN are in AP, then the general term is given by this. And the sum of the n terms of the AP is simply given by this formula. And if they are in GP, then well, we have these two formulas. The terms are increasing in a constant multiple of R, where R is simply the ratio between every successive term, and sum of n terms is A1 whole into R to the power n minus 1 by R minus 1. And finally, if A1, A2, AN are in HP, then 1 by A1, 1 by A2, all the way up to 1 by AN are in AP. Okay. Okay, so we have this sum. Let's name the sum as S and write it in summation formation. So we first need to understand how it's going about. What is the general term? So you can see it's 1 into 2 by 3 factorial, 2 into 2 square by 4 factorial, 3 into 2 cube by 5 factorial. So, well, okay, it's starting from 1. So k equals to 1. It is going up to 15. We can identify from this term, right? And what's happening? This is k. Well, this is always 2, but its power is k. And here, I think it's starting from k plus 2 factorial. This is our general term, and this is what we have to find. Okay. So what we can do here is this. Summation k equals to 1 to 15. We can write k plus 2 minus 2 into 2 to the power k by k plus 2 whole factorial. Okay, so when we do the distributive law and separate this, we get basically k plus 2 into 2 to the power k by k plus 2 factorial. So k plus 2 by k plus 2 factorial into 2 to the power k minus k equals to 1 to 15, 2 to the power k plus 1 by k plus 2 factorial. Okay. And this becomes k equals to 1 to 15, 2 to the power k by k plus 1 factorial minus k equals to 1 to 15, 2 to the power k plus 1 by k plus 2 factorial. And this is the point up to which I'm going to do. I'm not going to do it further. From this step, you should be able to find it in like one step. Okay, simply one step. The only hint I'm going to give is this is the telescoping series. If you do not know what that means, please Google it up because this is going to be very useful. So you can find it, and any series of the telescoping form simply has a simple, I mean, it has a simple answer always. It's a very specific form, and this right now, this expression satisfies the telescoping form. So, well, you have the answer.